Okay, so we're going to do division this time, not with just single sets of things in the bottom, single terms, but we're going to have addition and subtraction in the bottom. And we need to handle that a little differently with something we call the conjugate. Now, I'm going to take you back to something that you're familiar with to kind of help you relate to this. Do you remember back when you did FOIL in the last, I think the last section, I can't remember where, but they had a set that said 2 plus the square root of 6 squared, and that meant we had to write the sets twice at exactly the same set, and then we FOILed. And when we came up with the answer had a radical in it still. So that's why when we're doing this, our instinct is just to multiply by the same thing, but we can't do that because it'll still end up with a radical. But we can use another concept that we've worked on previously, and that is it's called the sum and difference of squares. And again with FOIL, when you have sets that look the same, but one of them says plus and one of them says minus, that's the key. They have to have opposite signs. See, if they have the same sign, you end up with the radical. But if they have different signs and you FOIL them, and this was true way back when you learned factoring, when you said x plus 3 and x minus 3, that it always produced the opposite sign for the middle two terms, and so they canceled each other out, and you had a two-term answer. And that's what we want to do here, because notice up here what caused this radical was that the O and the I had radicals in them, and that's what we were left with. So if we have the opposite sign, which is what we call the conjugate, when the con is like to be against or do the opposite, that's why they use that word prefix con. So if I had 2 plus the square root of 6 and I wanted to get rid of it in a fraction, I would multiply by 2 minus the square root of 6. Because watch what happens when you FOIL. The first in each set, and then the outer edges give me a minus 2 times square root of 6. Innermost gives me a positive 2 times square root of 6. And then we have this part. And notice that when we put these two together, they're opposites. Negative 2, positive 2, so they're gone. So then we just have to deal with this 4 and this negative 6 and put those together. No radical in the answer. So when we come over here to this part, we want to do the same thing. So if we have square root of 5 plus x, then we'll multiply by the conjugate, which is the square root of 5 minus x. And of course, like all the other times, we have to absolutely make sure we do the same thing on the top. It'll totally mess us up if we don't. All right, so when we do FOIL, to get the bottom of this, square root of 5 times square root of 5 gives you the square root of 25, which is 5. Outer edge is square root of 5 times a negative x, so it's negative x times square root of 5. And then the innermost is positive x times the square root of 5. So there's that beautiful canceling out stuff going on here. They're opposites, they're gone. Then the last in each set, we have a positive x times a negative x, which is a negative x squared. So that comes down here with this, it's a minus x squared. So the denominator now becomes 5 minus x squared, or negative x squared plus 5, whichever way you want to look at it. The top, we will distribute this 2. Be careful to make sure you do it to both things. So it's 2 square root of 5 minus 2x. And ta-da, we have rationalized the denominator. So here's the next one. Take a second, think about it. What do you think we're going to multiply by here? Okay, just the same thing, just the conjugate. And we'll do it on the top as well. And then we would go through the same process we did up above with FOIL on the bottom because there's 2 terms in each set, but just the distributive property on the top here.